Hello friends, welcome to our physics class. Today we shall look at the analytical derivations of the equations of motion as propounded by one of the founding fathers of classical physics, Sir Isaac Newton. Now, before we look at the first equation of motion, it is very expedient that we get ourselves fully acclimatized with the concept of acceleration as one of the important elements of dynamics. Now, we know that acceleration is simply defined as the time rate of increase in velocity. So, when the velocity of a body increases in value from u to v in time t, then the time rate of increase in the velocity of that body is given by a is equal to v minus u divided by t. Now, in this equation, when we cross multiply, we shall have v minus u is equal to at. Okay, now we now transfer u to the right hand side of the equation. So we are going to have v is equal to u plus at. And this is the first equation of motion. Now, in the second equation of motion, we're going to look at the concept of average velocity. Now, the average velocity of a body is given by half the sum of the initial velocity and the final velocity. Okay, now we are now going to substitute equation 1 into this equation. So, in other words, in this equation, anywhere we see v, we shall replace it with u plus at. So that means that average velocity is equal to half into u plus at. Okay, now this is equal to half into u plus u is 2u plus 80. So when we multiply through, we're going to have half multiplied by 2u plus half multiplied by 80. Now these two, we cancel these two. We are now left with u plus half at. Alright, but remember that the displacement of a particle s is the product of the average velocity and time. So s is equal to average velocity multiplied by time. Okay, now the displacement s is equal to, now the average velocity is u plus half at. So we have u plus half at multiplied by the time t. Okay, now s is equal to t times u will give us ut plus half at times t will give us half at squared. This is the second equation of motion. S equal to ut plus half at squared. All right. Now, let's look at the third equation of motion. Okay, now recall that from the first equation, we have v is equal to u plus at. Now, when we square both sides of this equation, we're going to have v squared is equal to u plus at all squared. And this is equal to u plus at into u plus at. Okay, now when we expand this bracket, we're going to have v squared is equal to u times u will give us u squared plus u times at will give us uat plus at times u will give us uat plus at times at will give us a squared t squared. Okay, now we're going to have v squared is equal to u squared plus uat plus uat will give us 2uat plus a squared t squared. Okay, now we have v squared is equal to u squared plus, now when we factor out 2a from this term and this term, we're going to have 2a into, now what remains here now is ut plus, and what remains here is a half a t squared, because 2a times ut will give us 2uat, and 2a times half at squared will give us a squared t squared. All right, now we are now going to substitute equation 2 into this equation, because ut plus half at squared according to this equation is equal to s. So this equation becomes v squared is equal to u squared plus 2as, because the whole of this parameter is equal to s. Now, this is the third equation of motion. Now, the fourth equation of motion, remember that the average velocity is equal to half the sum of u plus v. All right, but we know that the displacement s is equal to average velocity times time. All right, so now that means that the displacement s now is equal to average velocity is half u plus v. So we have half u plus v multiplied by the time t. So s is now equal to half u plus v multiplied by t, can also be written as u plus v multiplied by t divided by 2. Now, this is the fourth equation of motion. Thank you very much for your audience. Wait for us in our next class, and we're going to use these equations to solve analytical problems in motion. Don't forget to share our videos and subscribe to our YouTube channel. Thank you.